good day, good day. Once again, we meet and we are continuing our discussion on acids and bases. So if you haven't subscribed, please make sure that you do the right thing. And if you haven't watched the first video, we've already posted something on acids and bases. Maybe it's best for you to look at that before you continue with this one. However, today I want to just continue from where we left off. And last time we were talking about the Arrhenius theory of the acids and bases, and we talked about around the issues of titration, right? So today I want to just proceed from the Lowry-Bronsted theory, right, around acids and bases. And just to recap quickly what we said around acids and bases the last time. We said, well, the Arrhenius theory tells us that an acid is a substance that ionizes in solution, right, to give us hydronium ions, that's H plus ions, and then a base gives us hydroxide ions, OH minus ions, okay? So now, but we defined an acid according to the Lowry-Bronsted theory. Now I want you to please remember, we said, well, a substance, an acid is essentially a proton donor, right? So we said an acid as a proton donor. So it means that, by the way, when we say proton, it's the same as H plus, right? So this is where we are talking about the hydronium ion. So it's an H plus donor, and where we said a base is a proton acceptor, right? So according to the Lowry-Bronsted theory, a base is a proton acceptor. Now, please, I want you to remember how these actually just relate with one another, okay? So just remember that when we talk about the acid and base reaction in this case, we then begin to talk about the process of protolysis, right? Which means that it's the transfer of protons. One accepts and another one transfers protons, okay? So essentially, what I want us to quickly do is we're going to talk about how to calculate the pH, okay? The pH value for an acid. And this is the equation that we're going to use. It says the pH is minus the log of hydronium ions, okay? Concentration, so H plus concentration. Now, one thing that I want you to please note, I don't want to make this video very long, right? I want you to please note, and I'm going to show you just now, how this can also be written as minus the log of H plus ions. Now this is going to be very important, and I'm going to show you. So what does that mean? It means H3O plus and H plus is exactly the same thing, okay? So I'm going to show you in an equation whereby when we take H plus ions or H3O plus ions, it means exactly the same thing. So I want you to keep that in mind, okay? As we are going through this process, I want you to keep these in mind. H3O plus and H plus is exactly the same thing. Now, just for quickly, let's talk about, okay, how do acids ionize, okay? I'm going to show you that in just a few. Now, if you take an acid, let's say for argument's sake, hydrochloric acid, the process of ionization, we take hydrochloric acid and we react it with, or rather, we dissolve it in water, right? So we dissolve an acid in water. And by the way, you shouldn't do it the other way around, okay? You shouldn't pour water on an acid, okay? Otherwise, it will just simply explode on you, right? So in this case, what we're going to do is we say, all right, so what type of reaction takes place here? We know we are going to get H3O plus ions, and I'm going to show you where this comes from, and Cl minus. Now, you remember we said in this case, we can identify which one is the acid-base conjugate pairs, right? So what happened, okay, if you haven't seen this before, as I said, you should watch the previous video, right? So it means that hydrochloric acid, in this case, must have donated the H plus ion, and look at this, it became Cl minus, So in this case, because if it's an acid, it's an H plus donor, so this becomes an acid. Remember, we said that an acid is a substance that in this case donates H plus ions, right? So this guy becomes the acid. Now, what happened to H2O? It started as H2O, and what does it become? It becomes H3O plus. So what did it do? H2O must have accepted a proton, and as a result, because it is a proton acceptor, H plus acceptor, so this guy must be the base, right? So if you take the reverse reaction, we said H3O plus starts as H3O plus, but what does it become on the other side? It becomes H2O, right? So what happened to H3O plus to end up as H2O? It must have donated an H plus, and so this guy becomes the acid on this side, okay? And Cl minus obviously starts as Cl minus and it becomes HCl, so therefore it must have accepted an H plus, so this guy is now the base. So we said we can identify which ones are acid-base conjugate pairs, right? And we always said we take the acid on the one side together with the base on the other side. So acid on the one side, I'm going to pair it with the base on the other side. Okay, so that's my acid-base conjugate pair. And acid on the one side, pair it with the base on the other side. So these are my two conjugate pairs. So it's going to be HCl is paired with Cl minus, and as well as H3O plus is paired with H2O. And I did say to you, to identify this is quite easy, right? So in this case, what you simply do is you just look at the ones that kind of look similar, but the only difference between them is just the H plus. So you can see these look similar. The difference is that this one has got one hydrogen more than the other, right? The same with these ones, they look similar, and the one has got one hydrogen more than the other. Now, very quickly, I want to show you. We could have written this reaction in a different way. And what is that? Right? So essentially, what are we doing here? We are simply just taking hydrochloric acid, there's a tongue twister there, hydrochloric acid, and we are simply ionizing it. It means it's decomposing, it's breaking down, right? So in this case, we can write it in a simple way without necessarily showing the H2O, right? So HCl is now doing what? It's breaking down to become H plus Cl minus. It is breaking down, it's donating those H plus ions, okay? Now, ladies and gents, I want you to please listen carefully. What this simply means is that essentially, when you look at this reaction here and this reaction over there, that's exactly the same thing. What's the difference? The only difference is that I've shown you that that H plus ion actually sits on the water molecule H2O and therefore becomes H3O plus. So in a sense, when you look at this one, it's actually H2O with an H plus. Okay? So it's H2O with an H plus. So it's essentially that. So this is now where I'm going back to what I said at the beginning, that H3O plus and H plus are exactly the same thing. Okay, so in a sense, you've kind of repeated yourself by showing H2O there, right? So in this case, what I do is just eliminate the H2O and just show you the H plus. Now I'll show you why this is important. Now let's take another acid. It means that if I write the one for H2SO4, I must know how H2SO4, which means it's sulfuric acid, how does this one ionize, right? Now note, this is called a diprotic acid. What does diprotic acid mean? It simply means it's able to donate 2 H plus ions, right? So as a result, what does it become? It becomes 2H plus. Okay, and by the way, it does this in 2 steps, but I'm only showing you actually the final product, right? So H2SO4, right, becomes 2H plus, and the sulfate ion, that's that's SO4 2 minus. Now, ladies and gents, why is this important? I want you to please note. It means, let's take the first one, the one for hydrochloric acid. How does hydrochloric acid ionize, right? It means for 1 mole of hydrochloric acid, you see, for 1 mole of this, I will actually get 1 mole. Of course, assuming that it ionizes completely, right? We're going to talk about the strength of an acid just now, right? Assuming that it ionizes completely, it means for every 1 mole of this, I will get 1 mole of H plus, right? But look at this. What does it mean now for hydrochloric acid? For every 1 mole of this, I will get 2 moles of H plus ions. It means if I have any amount of hydrochloric acid, or if I know the concentration of it, it means the concentration of my hydronium ions will be twice as much. Okay, right, and that becomes very important. Of course, we say this is a monoprotic acid. It's able to just give 1 hydronium ion, and this is a diprotic acid. Of course, we do have other acids like phosphoric acid. I know this is a weak acid, and by the way, please just go through your list of strong and weak acids. You'll notice that there are actually just 3 strong acids. It's HCl, that's hydrochloric acid, okay? That's H2SO4, that's H2SO4, that's sulfuric acid, and nitric acid, HNO3. Any other acid that we mention is a weak acid. If it's not those 3, any other acid is a weak acid. Okay, so what about the bases? You have only 2 strong bases. That's your sodium hydroxide as well as your potassium hydroxide. Any other acid base rather that we mention should be a weak base, right? Now let's go back to this. We said H3PO4. What does it become? It becomes 3H plus, okay, plus PO4 3 minus. Okay, so notice it's got 3 hydrogens here, right? And as a result, it will give us 3 hydronium ions. Okay, ladies and gents, I want you to please note as we are about to do some questions. Okay, just keep this in mind. Okay, of course, we've got other types of acids. Okay, we've got what we call ethanoic acid. How does ethanoic acid ionize? So this is how we write ethanoic acid, or don't be surprised, sometimes they call it acetic acid. That's the old naming system, right? That's acetic acid. They still use that name, by the way. This is found in vinegar, right? So how does it ionize? It gives us 1 H plus, that H there, and then we have CH3COO minus. Okay, right, so that is how it would ionize. So in this case, ladies and gents, so what I want us to do, I want us to quickly do some questions. How to apply what we know now, into a calculation that involves the pH of an acid. Shall we do that? All right, I'm ready. So before we get into calculations, let's talk about the pH scale. What exactly is the pH scale? So the pH scale essentially is the measure of the acidity or the basicity of a substance, right? Now the pH scale starts from 0 to 14, where anything between 0 and 7, or anything less than 7, all right, is regarded as an acid, all right, with a pH of less than 7 is regarded as an acid. And anything with a pH of anything greater than 7, so between 7 and 14, that would be a base, right? Okay, so in this case, what we simply are saying is that when we take an acid or a base, how do we determine whether one is an acid or base? It will be based on the pH, okay? So it will be based on the pH that we determine, okay? So as a result, now please, I want you to note this. Even though you may have an acid or something that has a lesser than 7 pH, there are 2 types of acid really. There are strong acids, and by the way, the stronger an acid becomes, the lesser the pH becomes. So meaning that the ones that have a strong that are strong acids would lean more towards the 0 mark. Are you with me now? Right. So meaning anything that still has a pH of less than 7, but in this case leans more closer to 7, that would be regarded as a weak acid. Okay, now let's talk. What exactly is a strong acid? We say strong acid, it's one that ionizes completely in solution. I'm sure someone is asking themselves, all right, what exactly does that mean? All right, I want you to kind of imagine this. Okay, I always kind of use this example. This pen that I'm holding, okay, you can break it down into 2 parts, right? So the first part is, the pen part. I don't know what to call it, okay? And then you also have the lid, okay? So you can actually break it down. This is a complete pen, right? So what happens is that you can actually break this into 2, which is the lid and the writing part, okay? So an acid comes complete like this, okay? So what happens with an acid? What it does is that it breaks down to give you H plus, and then you have the other part, okay? Depending on which acid it is, right? So a strong acid, if you've got, let's say, 10 moles, 10 of these, all of them are able to actually break down into the H plus and the other part. Are you with me? But if you've got a weak acid, let's say you've got 10 moles of them, all right? You find that out of the 10 that you have, it's only 3 moles. I'm just making an example. Only 3 moles were able to break down. The rest prefer to actually stay as they are. All right? So in this case, how do we measure the strength of an acid? It's one that breaks down, ionizes completely, all right, in solution to give us a high concentration of our hydronium ions. A weak acid, it's one that ionizes partially, so not all of them are going to break down to give us H plus ions, right? So a base, by the way, we'll talk about this in the next video. We know the ones that lean more towards 14 are going to become strong bases, are the stronger bases, okay? And obviously leaning more towards the 7, that's the weak bases. But I want us to focus on this today, right? And as I did say, you've got 3 strong acids, right? So as we are going to calculate now the pH of an acid, I want you to note every time we're going to evaluate whether the acid is strong or weak, depending on the scale or depending on the pH that we determine. Okay, right, now I want us to get into the calculations, and I want us to note how to calculate the pH. Now, something that you must remember is that we said the pH, all right, is going to be minus the logarithm of our hydronium ion, H3O plus. But I did say to you, we can actually use H plus. It's exactly the same thing. I don't know if this looks like a 3. Right, so that's H3O plus, right? So I want you to note we can still even write this as minus the log of H plus. Let's get into it and see how to calculate the pH of an acid. Right, so we take 3 moles of hydrochloric acid, okay, that are dissolved into 10 cubic decimeters of water. Right, we want to calculate the pH. Now, the first thing that you're going to do, ladies and gents, is I want to know first, how does hydrochloric acid ionize? Okay, how does hydrochloric acid ionize? So I know that hydrochloric acid, we said HCl, all right? So I'm going to write the simpler form of it. How does it ionize? It gives me H plus plus Cl minus. Okay, so this is what I get, right? So I know this is how it ionizes, right? So in this case, I'm going to simply say, now, do I have the concentration of hydrochloric acid? Well, they gave us number of moles there, and they gave us volume. Is it possible for us to calculate the number of the concentration? And by the way, why am I looking for concentration? Remember that pH is minus the log of the concentration. So I need to always have the concentration. I cannot use number of moles. I cannot use volume. I can't use any other amount, by the way, except for concentration. So in this case, I'm going to say, let's find out the concentration of the acid. So I'm going to simply say number of moles. Number of moles is concentration times the volume. Remember, this comes from your C is equals to N over V formula, right? So I know number of moles is concentration. By the way, in fact, I should have kept it in that format. So concentration is number of moles over volume, right? So number of moles over volume. So number of moles, that's 3, right? That's 3 moles. And my volume, by the way, please always make sure that that volume is in cubic decimeters, which it is in this case. So I say divide that by 10. So 3 divide that by 10, that will give me 0.3 moles per cubic decimeter. Now, question is, can I now calculate the pH? No, I can't. Remember, what did I just find? I found the concentration of HCl. And note, and this is a very common error that people make. Then they will say, oh, but I know pH is minus the log of HCl. Please note, please do not change the equation, right? It does not say minus the log of the acid, but what should be in here? The concentration of what? H plus. All right? H plus. So this would be incorrect. Are you with me? So now I'm going to say, all right, do I have the concentration of the H plus? What I've found here is the concentration of the HCl, right? Hydrochloric acid. But I want to find out the concentration of my hydronium ions. Can you see? So I'm going to say, right. So for every one of this, I get one of that. Okay? I can do this with concentration because it's in the same volume. Okay? So in this case, I can say, well, for one of this, I can get one of that. So it means for any amount of hydrochloric acid, if it ionizes completely, I will get the same amount of what? Hydronium ions. Can you see that? So in this case, I can therefore say, note, I can conclude that it means that the concentration of HCl should therefore be equal to the concentration of my hydronium ions, or you can just put it as H3O plus, nothing wrong with that. And what is that concentration? We said that concentration is 0.3 moles per cubic decimeter. Okay, right. Now that I have the concentration of H plus, can I now calculate the pH? And yes, we can. Please remember, you are not to calculate pH based on the concentration of the acid. We're looking for the concentration of what? The hydronium ions. So now I can simply say, all right, so my pH value, all right, is going to be minus the log of my hydronium ions. You can write this as H3O plus. Remember, we said it's the same thing as H plus. Okay, nothing wrong if you maintained it as H plus. So that's minus the log of, now note, when you substitute, remember these square brackets denote concentration, right? But when I substitute now, I'm going to use round brackets. Why? Because I don't want to say the concentration of the concentration, right? So let's take our calculator and say, okay, we're going to say minus the log, okay, minus the log. What is our value there? Of 0.3 0.3. Okay, so of 0.3, and we find our answer. I get an answer of 0.52. What does that say to us? Okay, remember our pH scale, right? So what does that say to us? pH of 0.52, of course it's leaning more towards the 0 mark, isn't it? So it tells us that hydrochloric acid must be a strong acid in that case. Of course, we know that we've already said that before, right? All right, now let's take another question. Right, let's talk about the next question. So I thought I'd hit two birds with one stone on this question. You'll understand as I go on with this question. So I thought I'd just remind you just a little bit on stoichiometry. For those of you who've kind of forgotten, I've gotten quite a lot of questions on that. Okay, and then also obviously we want our focus here is calculating the pH, right? So now they give us a standard solution, okay, or rather they say a standard solution of sulfuric acid is prepared by dissolving 5 grams of the acid into 800 cubic centimeters of water. Now, I want you to please note what is a standard solution, right? So what is a standard solution? A standard solution is a solution with a known concentration. So just please remember that. So when we talk about a standard solution, we're talking about a solution with a known concentration, or whose concentration is known exactly, right? So in this case, remember, what do we need to calculate pH? We need the concentration of the hydronium ions, okay? So let's start here. So they give us sulfuric acid. They say we took 5 grams and we dissolved it in 800 cubic centimeters of water, right? So let's first of all find out, okay? How can we find out the concentration of the acid, okay? Of course, this is not the pH calculation. We'll get into that just now. So we'll say, because we are given the mass of the acid, we know we can use the formula concentration. And by the way, maybe I should just get your formula sheet, your data sheet closer here, so that you can see all of this. Remember that you're given, right? So it's that formula there, concentration, that's mass over molar mass multiplied by volume. Can you see that? Okay, so we know concentration is going to be mass divided by the molar mass multiplied by the volume. Now let's check. Do we have the mass? Yes, we're given that as 5. Okay, molar mass. All right, so where are we going to get that? Remember, sulfuric acid, the formula of sulfuric acid is H2SO4. Now, as I said, I'm going to actually, this lesson just serves as a reminder to some of you who may have forgotten. So how do we get the molar mass? This is where I go to my periodic table. Let me get that table here. Right, so this is where I go to my periodic table and say, well, look, how many hydrogen atoms do I have there? I've got 2. What's the molar mass, or what's the relative atomic mass of hydrogen? It's 1. It's that value there, right? So it means when I calculate the molar mass of H2SO4, okay, so that molar mass will be 2 hydrogens. So it's 2 multiplied by 1. Why am I multiplying? I'm saying it's 2 hydrogens, and the molar mass of hydrogen is 1. There it is there, right? So that's 2 times 1 plus. Now please remember, you add when you go to a different atom, right? So I'm now adding the molar mass of sulfur, right? So the molar mass of sulfur, okay, so there's my sulfur molar mass there, it's 32. So it's plus 32, okay, plus, and I'm adding again, so I'm going into a different atom, right? So plus, okay, I've got 4 oxygen atoms, so I'm going to say 4 multiplied by, what's the molar mass for oxygen? There it is there, that's 16. So in this case, I'm going to say 4 multiplied by 16. Remember, I'm doing this for some of you who may have forgotten about this part of chemistry, right? So in this case, I'm going to say, so that's 2 times 1 plus 32 plus 4 times 16, and I get a value of 98 grams per mole. Okay, please don't lose track. What are we trying to do? We're trying to get the concentration of sulfuric acid. So I know my molar mass value is 98 there. Okay, all right, so my molar mass value is 98 multiplied by the volume. So where do I get the volume? I'm given in the question. They said it's 800 cubic centimeters. Now please, I want you to keep in mind that when you use this formula, in fact, anytime I deal with the number of moles over volume, my volume always needs to be in cubic decimeters, right? So how do I convert that into cubic decimeters? When you're given cubic centimeters, you just simply divide by 1,000. Okay, let's not overcomplicate it. So my volume will be 800 divided by 1,000. Okay, and I will get 0.8 cubic decimeters. Okay, so now I know this is 0.8. Okay, so then let's just do a quick calculation, right? So I'm going to say 5 divided by 98 multiplied by 0.98. Okay, all right, I get a value of, okay, 0.06. I'm going to round it off to 2 significant numbers, so I get a value of 0.064 moles per cubic decimeters. Okay, right, sorry, I'm trying to squeeze all of that there. All right, so there is my calculation over there. So this tells me, okay, so I wanted to find out what is the concentration of my acid. So that is the concentration of sulfuric acid. Now, the next question, they say calculate the pH of the solution. So I want to know what is there, or how do I get the value of the pH? Now, ladies and gents, please, please, please don't disappoint me now, right? Can I calculate pH now? Absolutely not. Why? Because I do not have the concentration of my hydronium ions. Yes, I have the concentration of the acid, but I don't have that one of the hydronium ions. So how do I then calculate concentration? I'll say, well, concentration of my hydronium ions. Remember, how does sulfuric acid ionize? Remember what I just showed you now, right? Sulfuric acid, when it ionizes, okay, so these are half arrows, sorry. So we said it is a diprotic acid, so therefore it will give me 2H plus, and I'm left with SO4 2-. Please, this is very important for us to know. Why? Because now I know the concentration of the acid, but I do not know the concentration of my hydronium ions. Okay? Then I'll say, okay, for every one of this, I'll get 2 of those. Can you see? So I say, for every 1 mole of the acid, okay, maybe let me write it down in ratio and proportion to show you how to do that in a much simpler way. I'll say, well, for every 1 H2SO4, okay, I get 2 hydronium ions. That's given, isn't it? Okay, so now how many, what's the concentration of sulfuric acid? I said you put the same thing on the same side. So for 0.064 64 of sulfuric acid, which is the concentration of sulfuric acid there, how much, okay, of hydronium ions, what would be the concentration of hydronium ions would I have? So let me put H plus concentration there, okay, or you can say N concentration, okay. No, maybe let me not use N, let me use X, okay. So for how much, all right, what would be the concentration of your hydronium ions, okay? So then you can cross multiply. I didn't really want it to be confusing, okay, so I'll say X times 1, that will give me X, okay? And 0.064 times 2, okay? So 0.064 times 2, that should give us 0.128, okay? So it means that the concentration, 0.128, that's moles per cubic decimeters. Right, let's not make it complicated, ladies and gents. What is this? This is the concentration of my hydronium ions. Look at this. For every one of that, there's 2 of those, right? So if I've got 0.064 of this, I'll get twice the amount of hydronium ions. And what's twice the amount? It's this amount over there, which is 0.128 moles per cubic decimeters. Okay, I hope you're still following on what I'm doing, right? Now that I've got the concentration of my hydronium ions, can I calculate the pH? Absolutely. So now we can say, all right, what is the pH? That's minus the log of hydronium ions. Remember, it's not minus the log of H2SO4. No, you can't do that. It's illegal. So minus the concentration of my hydronium ions. Okay, now that I've got the concentration of the acid, I got the concentration of the hydronium ions, and therefore that will be minus the log of, now once again, round brackets, right? So in this case, that's 0.128. Note, I'm using the concentration of the hydronium ions, not that of the acid, okay? And what do we get there? Okay, so we'll put that in the calculator. That's minus the log of 0.128, and all right, I get a value of 0.9. So I'm going to just round it off there, get a value of 0.9. Okay, so that would be my pH value. All right, so what does that mean about sulfuric acid? It means that it would be a strong acid. Okay, right, ladies and gents, I want to keep it here. Just a word of caution and a word of advice. Okay, I just gave you 2 examples where in one we were given number of moles and in another we were given the mass. Obviously, if I were to be given the concentration, you wouldn't need to go through all of these gymnastics, right? All you'd have to do is, if I'm given the concentration of the hydronium ions, right? The concentration of the acid, I would use this formula to find out the concentration of my hydronium ions, and as a result, I would be able to just simply calculate the pH. I hope that makes sense. I hope we can all understand that. Okay, and I think I just wanted to close now, but I'm just thinking to myself, perhaps maybe let me just show you what to do when you are given the pH and you want to determine the concentration or the mass or whatever the case may be. Right, let's just take one more example of that. Right, so our last question. So they say the pH of a nitric acid solution is 1.4. So we need to calculate the concentration of nitric acid. Okay, so when you are given the pH and you want to determine, now you want to work backwards, the concentration. Now please, I want you to note, we're going to start here. Obviously, our formula for pH, that's minus the log of our hydronium ions. And please note that hydronium ions is exactly the same as H+, right? All right. So please, I want you to note, okay, all that you're simply going to do when given the pH, and now you want to calculate the hydronium ions. Okay, let's first start by substituting. So I'm going to say, okay, so that's 1.4. Remember that pH was given as 1.4. That's minus the log of H3O plus. Now, this is when you want to work with anti-logs and you are now working back from logs to exponents. Okay, but please don't make it complicated for yourself. This is not a maths exam, okay? All that you simply do when you are given the concentration, so all that you do for pH, so all you'll say is H3O plus concentration or H plus concentration will always be 10 to the minus pH. Okay, so if my pH is 1, what will it be? So it will be 10 to the minus 1. Okay, if my pH is 1.4, what will be my concentration of hydronium ions? It means that concentration of my hydronium ions, all right? Please don't ask me many questions. How did you get to that? For now, let's focus on this, right? So H3O plus will just simply be 10, okay, base 10 to the minus pH. We'll have a maths discussion about it someday, okay? Right, so in this case, that's 10 to the minus 1.4. And what do I get for my pH value? So all I'll just simply do, just grab my calculator there and say, okay, this is 10. That's my y-axis. That's minus 1.4. Okay, and I get a value of 0.004. Okay, so it means that my concentration is 0.04 moles per cubic decimeters. Now, what did I just get, ladies and gents? What did I just calculate now? I calculated the concentration of my hydronium ions, but the question said calculate the concentration of what? Nitric acid. Okay, so now I need to know, how does nitric acid ionize? Okay, so HNO3 becomes H plus NO3 minus. Okay, so I know for every one hydronium ion, right, I will get one of that. Okay, look at that. For every one, there's one. So it means the concentration of my hydronium ions, remember this in the same volume, the concentration of my hydronium ions will be the same as the concentration of my nitric acid. Why? Because 1 is to 1. So as a result, I can say, therefore, concentration of HNO3, okay, should also be equal to 0.04 moles per cubic decimeters. Okay, right. Obviously, if they give us sulfuric acid, we would have actually halved that. Okay, but that's another discussion for another day. I wanted to make this sweet and short. I hope, ladies and gents, this will be beneficial to you. Otherwise, I'll see you next time. Please don't forget to subscribe. And, you're more than welcome to tell more people about this platform, all right? If you're benefiting from it and it's helping you, obviously, just extend the courtesy to others. Otherwise, I'll see you guys next time. Thank you. Sharp, sharp.